In this video, we're going to talk about the inversion of control, which is the IOC principle. So if we grab the diagram from the previous video and paste it over here. So we have a higher component that uses a lower component through the interface. So without the inversion of control principle, what's going to happen is that although we're working through this interface, we are still using the lower component inside the higher component. And it's going to be inevitable to do something like this. So a higher component still uses the lower component through the interface. So it's going to still instantiate this lower component inside it. Inside the code, it's going to be something like this. I'm temporarily going to delete this. So without this being passed in from outside, what we have to do is to do something like this. So employee repository, but we will have to instantiate it from here, right? So this although compiles, but you can see that although here, this employee's repository variable is of the type employee repository, but it's actually instantiated through the employee's repository, which is the concrete implementation, which means that first of all, this still breaks the dependency inversion principle. The higher component is still dependent on the lower component. And secondly, we are controlling the creation and deconstruction of the lower object here. So this object is going to be created inside here and it's going to be disposed inside here. We're creating the lifespan of the lower object. In turn, this doesn't solve the dependency problem that we talk about in this chapter. So in order to make this whole thing work, right, you utilize the dependency inversion principle, then we will have to use the inversion of control principle. The inversion of control principle says that the higher object is not going to instantiate the lower object. The lower object is going to be instantiated from outside of both the higher object and the lower object, and then it's going to be passed into the higher object. Right? That's why I did something like this in the previous video. We have this interface defined as the parameter, and then something else is going to instantiate the lower object to the concrete implementation and then passed in as the interface through this endpoint handler parameter here. So what is that something? Who's responsible for instantiating this and then pass into our endpoint handler here? From our diagram, it's going to look something like this. So instead of having the lower component directly referenced in the higher component, what's going to happen is that the higher component is going to only reference the interface for the lower component. Okay? It's going to reference that. And then the lower component is going to be instantiated from somewhere else outside of the higher component and then passed into the higher component through the interface, something like this. Then who is going to be creating the instance of the lower component and pass into the higher component? Well, definitely it's going to be our ASP.NET Core framework, right? The ASP.NET framework as a framework is responsible for creating an instance of this and then pass into it. But what exactly does that? Well, in the program.cs, we have seen the services collection and we have used it a few times already. In this case, we add problem details into the services collection, right? And then later we're using those problem details right here in the exception handler. Although we don't see the exact code that is doing that, but we are going to implement that ourselves. So what we are going to do here is we're going to define a new concept here, which is this service collection that is called dependency injection container or DI container. This container allows developer to register the mapping between, so I'm going to just directly add the code and then explain later. So I'm going to map the abstraction and the concrete implementation through this method. And once this is mapped together, the ASP.NET Core framework knows that in the framework, the concrete implementation of this abstraction are both registered. And also there are matching, right? So this concrete implementation basically implements this abstraction. And then inside the framework, whenever this interface is required, this DI container is going to fulfill the dependency injection action, right? Which means that it's going to create an instance of this concrete implementation to match this interface. The concrete example that we have is that if we go to our endpoints class here, we have all of these defined as a parameter of the endpoint handler. So basically the endpoint handler is asking for an instance of this iEmployee repository type because this one is already registered in the program.cs file, right? This matches this interface. Therefore, ASP.NET Core is going to create an instance of this and then feed that to our endpoint handler through the parameter here. And then we can directly use it. So now the creation and the disposing of the repository object is done outside. It's not controlled by the higher component. So therefore, we achieved loosely coupling of the higher object and the lower object. Now we can say the higher object and lower object has nothing to do with each other, except that they're working with each other through this interface. And then our framework is responsible to create the lower object to match the abstraction and is also responsible to inject the instance of the object into wherever that is asking for the abstraction. So that's the implementation of inversion of control principle in ASP.NET Core framework, right? ASP.NET Core framework achieves that IOC principles with this dependency injection container. And then whenever you ask for an instance of the abstraction, the container is going to be creating an instance of this and feed it into it. So this is called parameter injection. And we have a different way to inject into our higher component, and we're going to talk about that later when we talk about MVC controllers. Right now in our minimal API, we're going to use this type of injection, so that we can use it directly inside our method, the minimum API method. At this moment in our code, we're actually having an issue, and that issue has something to do with this add transient method. There's three methods we can use in order to create a mapping between the abstraction and the concrete implementation, and we're going to talk about it in the next video when we talk about lifetime management. I'll see you in the next one.